Scientists not only study planets, but also pay attention to their weather. In the solar system, the diameter of a planet storm reaches 1.3 times the diameter of the Earth. Its intensity is unimaginable. This planet is Jupiter. Jupiter's mass is 2.5 times the mass of all other planets in the solar system. It is equivalent to 317.8 times the mass of the Earth. Its volume is 1,300 times that of the Earth. However, today, thanks to advanced technology, human understanding of Jupiter has already surpassed the knowledge of its quality and volume. Astronomers attach great importance to Jupiter's research because the future of the Earth is somewhat closely related to it. The latest data shows that some strange phenomena are taking place on Jupiter. Jupiter is known as the super vacuum of the solar system. This nickname comes from its huge gravity field and the position of its inner solar system. Jupiter has been hit by many small planets that may attack the Earth. For example, Schumacher was the 9th planet in 1994. When it hit Jupiter, it split into pieces. However, Jupiter's gravity does not always protect the Earth. In fact, it has a profound impact on the Earth's climate with Jupiter. Every 40.5 million years, the gravitational fluctuation between Jupiter and the Earth will cause unusually cold winters and cool summers. As a result, droughts and floods have become more serious. Studies show that we are now in the middle of this cycle. If Jupiter is in trouble, the Earth will also be greatly affected. One of the strangest phenomena on Jupiter is its famous storm, the Great Red Plateau. What is confusing is that this storm is gradually shrinking. Scientists have not yet figured out what the impact of Jupiter will be. The Great Red Plateau is a huge atmospheric storm on Jupiter. Compared to the largest hurricane on Earth, which has a diameter of more than 1,600 kilometers and a wind speed of up to 320 kilometers per hour, the scale and power of the Great Red Plateau is enormous. Its diameter is about 160,000 kilometers and the wind speed is up to 650 kilometers per hour. Since the discovery of astronomy in the 17th century, this storm has been the focus of scientists' research. The unique red color of the Great Red Plateau has been a mystery for many years. Some scientists believe that this color comes from complex organic compounds. These substances are rolled into high-level atmosphere from Jupiter. Some other studies point out that red may be caused by some chemicals in the upper atmosphere of the solar storm. If so, the color of this storm itself is not the real red. What we see may just be traces left by the sunlight burning at the top of the storm. The life of other atmospheric storms in the solar system is not as good as Jupiter's. For example, although the Great White Plateau on Jupiter covers thousands of kilometers, it appears once every 30 years and disappears quickly. The Great Dark Plateau on Neptune was discovered in 1989. Its wind speed is up to 2,400 kilometers per hour and reaches the supernova level. However, this extremely active storm disappeared in 1994. Let's go back to the topic of the Great Red Plateau. In 2019, the U.S. National Aeronautics and Space Administration's Juno probe flew over the storm twice and took pictures, provided scientists with more clues. Using the observation data of the Juno probe, scientists built a three-dimensional model of Jupiter. They found that the depth of the Great Red Plateau is far beyond previous knowledge. If on Earth, the height of the Great Red Plateau will exceed the orbit of the International Space Station. According to the study, the storm will look like a thick pancake, extending about 500 kilometers from the Jupiter cloud layer. This is equivalent to 50 to 100 times the depth of the ocean on Earth. The power source of the Great Red Plateau comes from a 3,000-kilometer deep airflow. The movement mechanism of these airflows is still a mystery that scientists are trying to solve. At present, the only clue comes from the data of the probe. There are up and down fluctuations in the airflow. This is completely different from the atmospheric phenomenon on Earth. The weather on Earth is mainly driven by moisture, cloud layers, condensation, and sunlight. The storm on Jupiter is driven by a completely different mechanism. When the Juno probe flew over the Great Red Plateau, the experience was like a car driving on a bumpy road. Scientists measured the slight fluctuations in the power of the storm through the microcompression and stretching effect of wireless radio waves to calculate its power. As a result, it was found that the gravitational force of the storm even made people wonder if there was a mysterious star hidden at the bottom. However, it was obvious that there was only a gas structure at the bottom of the storm. At the same time, the new observation data of the Hubble Space Telescope showed that the shape of the Great Red Plateau gradually changed from an ellipse to a circle, and its scale was significantly reduced. In the past, the area of the storm was enough to accommodate 3 Earths, but now it can only accommodate 1. From 1995 to 2019, through the images taken by Hubble, we can clearly see the significant reduction of the Great Red Plateau. Does the reduction of the Great Red Plateau mean its disappearance? If the storm disappears completely, do we need to worry about it? According to research, some unknown force in Jupiter's atmosphere is consuming this storm. In 2017, the Double North Telescope captured a small star cloud that looked like a hook on the west side of the storm. At the same time, it observed a wave-like structure on the east side of the storm. The image of the Middle North is also shown. The Great Red Plateau is showing red fragments. Some of these fragments are up to 100,000 kilometers, which is equivalent to the area of a grapefruit or an iceberg. The computer simulation shows that this is a very natural phenomenon in Jupiter's complex atmosphere. It may be the result of the interaction between the Great Red Plateau and other small storms. In Jupiter, the anti-gas spiral tends to attract each other, and the gas spiral and the anti-gas spiral will reject each other. When two anti-gas spirals approach, the small storm will gradually melt into the large storm, and when the gas spiral meets the anti-gas spiral, the rotation of the two will temporarily stop, and then split and scatter with incredible force. When the small anti-gas spiral approaches the Great Red Plateau, they will not fuse, but will be torn into fragments and separated from the storm. This is the phenomenon observed by astronomers today. According to scientists, the Great Red Plateau may disappear completely in 20 years. Although Jupiter itself is unlikely to be significantly affected, the existence of this storm may prevent some irreversible progress, which may bring unknown consequences after its disappearance. However, the current data also shows that between 2009 and 2020, the wind speed around the Great Red Plateau increased by 8%. This means that the activity of the storm is not weak, and may even expand again, or may be replaced by another storm. For example, in 2000, the three white small spirals on Jupiter merged. At the end of 2005, a new storm formed and gradually turned red, which was called the Little Red Plateau. In 2006, the Little Red Plateau and the Great Red Plateau had a slight contact and had little impact on each other. But how the relationship between the two storms will evolve in the future is still unknown. In order to further unravel the mystery of the Jupiter storm, the U.S. National Air and Space Administration has extended the Hubble mission to monitor the atmosphere of Jupiter, the magnetic field structure, and the phenomenon of the Great Red Plateau. In addition, Jupiter is still under close attention by the Hubble telescope, the microscopic telescope, and the Earth Observatory.